In this video, we'll show you some basic Excel skills, specifically how to create, copy, and paste formulas, how to make and format graphs with error bars and trend lines, and two different ways to find a slope's uncertainty, linear regression within Excel and graphical analysis on paper. We're going to start with some sample data. In this case, we have 6 different heights, and for each height, we have 5 time measurements that we wish to average. To accomplish this, we will use the AutoSum drop-down menu and select Average. This will insert a formula into the cell and will suggest a dataset to average. If its suggestion is not what you want, you can click and drag the cells you do want, then hit Enter. You can copy and paste this formula into the cells below by selecting it and clicking and dragging the lower right corner of the cell downwards. Note that the row reference changes as you paste into a different row, so in this case, each pasted cell only averages the cells in the same row. Next, we want to calculate the experimental error for the 5 time measurements at each particular height. To do this, we will calculate the standard deviation of the 5 measurements and divide by the square root of the number of trials, which is 5 in this case. Further explanation of this can be found in your Introduction to Experimental Physics lab manual. Standard deviation is not one of the common formulas found in the AutoSum menu, so we will type it in manually. Begin a formula by typing equals. The Excel formula for standard deviation is STDEV followed by the cell range in brackets as shown. Use a slash for divided by and SQRT for square root. As before, we will copy and paste the formula throughout the column. Similarly, we will calculate t squared, the quantity we wish to graph, and the uncertainty on t squared according to the appropriate formula. We can drag 2 formulas at once to fill out the columns. Next, we'll create a graph. I find it most convenient to select the data to be graphed first, although this is not strictly necessary. Once the data is selected, click the Insert tab. From the Charts section, select Scatter. For most physics purposes, the first option, Scatter with only markers, is the most appropriate choice. Depending on the order of columns you're plotting, you may need to switch the X and Y axes. To do this, right-click on the graph and click Select Data. Click Edit and switch the contents of the series X and Y fields. Now that each variable is graphed on the proper axis, you may need to adjust the scale for each axis. To do so, double-click the numbers corresponding with an axis. Change from auto to fixed and set a value as appropriate to maximize usage of graph space. Next, we'll format our graph. Generally, you'll want a title and a label for each axis, so click the Design tab and then the chart layout indicating those labels. Click inside the title to change the text as desired, and repeat for each axis label, making sure that you remember to add units. You may also wish to delete or alter the series legend, especially if you only have one set of data. Next, we'll add vertical and horizontal error bars to our graph. Click the Layout tab, then Error Bars, then More Error Bars options. Note that it will default to adjusting the vertical error bars. If you want a fixed error bar value for each point, you can enter it in the Fixed Value section, and we will do so for the vertical bars in this case. Note that it is possible for the error bars to be too small to be visible on an appropriate scale. If this happens to you, it is usually a good idea to explicitly mention that in your report. When you click Close, you will notice that both vertical and horizontal bars have been added. You can double-click on the horizontal bars to edit them as appropriate. If you want custom error bar sizes for each point, you can select Custom and click Specify Value, then select a data column with uncertainties in it. You may need to move the error bar properties window out of the way to do so. Note that you will need to specify both the positive and negative directions because Excel allows for them to be different. When your data appears to approximate a smooth curve, you should include an appropriate fit. In this case, as with most cases in first year, the data appears linear, so we'll add a trend line. Right-click on one of the data points and click Add Trend Line. Ensure that linear is selected, and check the boxes indicating to display equation and R-squared value. If necessary, drag the equation into a suitable part of the graph where it is not interfering with the data. To perform linear regression in Excel, you require the Data Analysis button, which will be displayed at the top right of the Data tab if you have enabled the Analysis toolpack. If you don't see this button, you can enable it by clicking File, then Options, then Add-ins, then Go, and checking the boxes by Analysis Toolpack and Analysis Toolpack VBA. Click OK, and now you should see the Data Analysis button. You will only need to enable this once. Now that the button is visible, click it and select Regression and click OK. Next, select your X and Y columns and click OK. This will create a new sheet with a number of values. For the purposes of this course, the 4 values highlighted are the important ones. X variable 1 means slope, coefficient indicates the value of the slope, and standard error indicates the slope's uncertainty. An alternative method for finding the uncertainty on a slope is called graphical analysis. This means drawing a max slope and a min slope on the graph and comparing them to the line of best fit. In our example, we're only considering vertical uncertainty for simplicity. However, the same principles apply when horizontal error bars are also present. We'll start our first line at the lower bound of the first point's error bar and end at the upper bound of the last point's error bar. In this case, the line goes through all data within uncertainty. Our second line will begin at the upper bound of the first point's error bar and end at the lower bound of the last point's error bar. This time, there are a couple of points that do not fit the line within uncertainty. It would be acceptable to adjust the line to fit those points. However, we will carry on this way because it results in a larger error value. As a reminder, to calculate the slopes of your lines, take the rise over run over a wide distance. Once you've found both slopes, compare them to Excel's fit slope and use the one that's farther away to establish an uncertainty. Make sure to round slope and uncertainty to the appropriate significant figure.